Professor Leslie Brent, it's a great honor to have you here with us at our annual meeting in San Diego in 2014. The International Society of Heart and Lung Transplantation launched a number of years ago what we call the History Project, in which we collect reminiscences and thoughts and comments from individuals who've had a major role both in the evolution of the field of transplantation as well as an impact on our society. And so we're very grateful that you could join us here today.
It's a pleasure for me. Thank you for inviting me.
So starting perhaps with a little bit about your background and your education, you were born in what is now Poland and came to England under quite distressing circumstances as a youth. Despite the difficulties of your childhood, you gained what seems to be an excellent education and were well-rounded in your primary school days in sport and music. How did you first become interested in science?
We had a very good biology teacher in my school in Kent. No science was taught because we didn't have a laboratory, physics or chemistry laboratory, but we had a good biology teacher, and he aroused in me an interest in biology. So I pursued that later on. I left school at the age of 15 to earn my living as a laboratory assistant in a chemistry department, which seems rather strange because I knew no chemistry whatsoever, but learned it very quickly. And I took evening classes in chemistry, physics, and biology. That helped me later, after having served in the army for 4 years, to get a Ministry of Education grant for ex-servicemen to study zoology at Birmingham University.
Oh, I see. And so you went to Birmingham University then after the war based on this?
That was in 1947.
1947.
Yes.
And in your memoir, you describe meeting Rupert Billingham at Birmingham University.
Yes, he was already a postdoctoral fellow in Peter Medawar's department, and collaborating with Peter Medawar in those days in Birmingham on the effect of corticosteroid hormones on skin graft rejection. And they did this very interesting work on cattle dizygotic twins. This was a strange project because Peter Medawar had been told that this was an agricultural problem, discovering dizygotic twins as opposed to monozygotic twins, because in dizygotic cattle twins, the female is always sterile. It's called a free martin because of the vascular anastomosis between the two and the passage of male hormones into the female. So the female is always sterile, and this is a problem which farmers found difficult to cope with because morphologically they couldn't tell the difference between the twins. And Peter Medawar said, oh, well, that's very easy. All I have to do is exchange skin grafts between them. And that's where the story began. And to their astonishment, they found that both dizygotic and monozygotic twins accepted their skin grafts perfectly well. I don't quite really, looking back on it now, I don't quite see this as a viable test for farmers exchanging skin grafts. But it was an interesting attempt to distinguish between these two types of twins.
Back at that time, which would have been about 1950 or so, I guess, or 51, immunology was just beginning as a field, wasn't it?
Yes. It was in a very primitive state, actually. I mean, we knew about antibodies. We knew the different classes of antibodies. We had no idea about the structure, which was elucidated much later by my predecessor at St. Mary's Hospital Medical School, Rodney Porter, in the 1960s. One knew about complement. Cellular immunology hadn't been invented. Certainly one knew about lymphocytes, but lymphocyte was regarded as a kind of end cell of no particular importance. Yes, I think our knowledge of the intricate nature of the immune response was very, very primitive.
So around the same time then, there had been the work of Ray Owen, who also on dizygotic cattle, describing the persistent chimerism. And also, I guess around the same time, in the same decade anyway, Sir Frank McFarlane Burnett and Frank Fenner were also working on things that eventually were elucidated as part of the immune system and perhaps the clonal nature of lymphocytes and so
Yes.
on. But the coming together of these lines of thinking and these threads of what were then probably relatively vague ideas must have been intellectually incredibly stimulating.
Yes, it was really quite accidental in some ways. Burnett and Fenner published this very fine monograph called The Production of Antibodies in 1948. And Burnett was a great reader of the literature, and he discovered this paper by Ray Owen, which Owen had published in 1945, which the immunological community had completely ignored, was completely ignorant, either ignorant of, or hadn't really considered its implications.
And it was in Science, so it was in a...
It was in Science, in a very, very, very fine journal, but a 3-page paper. And Burnett discovered this paper and realized its implications and built it into his theory of antibody formation with Frank Fenner. And this monograph of theirs was published in 1948. Peter Medawar had been asked to review it for some journal, I don't know which one. And in reviewing the monograph, he realized the importance of Owen's observations, which were quoted by Burnett and Fenner. And that helped him and Billingham to explain their own data, because until then, they were completely dumbfounded by their contradictory results of both kinds of twins accepting skin grafts.
So before they discovered this work of Owen's, they must have been very hard-pressed to...
They were very hard-pressed to know how to interpret their data, yes.
What kind of ideas did they think could be causing the acceptance of those grafts?
I'm not sure.
Perhaps some immunologic deficiency or something.
They were just very much taken aback.
So it was really quite fortuitous that Peter Medawar was asked to review Owen's paper, or found himself reviewing this paper,
Yes.
that had been largely ignored by anyone who was doing what was to become immunology.
Then, of course, in their publications on their cattle data, they quoted Ray Owen at length and gave him very full credit for having made that very astonishing discovery, which came totally out of the blue. I mean, there was no precedent of any kind.
What an exciting time then ensued.
Yes, very much so.
So just back a moment though, you were originally heading to Cambridge to do a postgraduate work in education.
You've obviously done your homework very well. Yes, I had intended to become a schoolmaster, as teacher, and I had applied to Cambridge University for a postgraduate diploma in education. When Peter Medawar, towards the end of my last year, approached me, he had been my professor in Birmingham. He had taught us some immunology, which I became very interested in. He also taught us statistics. And he asked me whether I'd like to become a student of his and to work on a topic called immunological tolerance. And as I had been exposed to a lot of racial intolerance in my early life, I thought that working on immunological tolerance sounded very exciting to me.
Sounds very good. It sounds like destiny, in fact.
And I immediately accepted the invitation. I cancelled my application to Cambridge University and never looked back.
And it sounds from descriptions that I've heard that Peter Medawar's Department of Zoology at University College London was a very interesting place.
It was a very fascinating intellectually and politically as well, because many of the staff were very left-wing. Haldane had a room in the department which Peter Medawar had allocated to him, where he wrote his obtruse theoretical papers on genetics. There were a number of very left-wing lecturers. Several of them were communists, members of the Communist Party. And Peter Medawar himself just rose above all this. I mean, he didn't sort of involve himself in the political side of the discussions, but he tolerated many people with many different viewpoints. And of course, after 1956, several members of the department left the Communist Party in a great hurry, having been shocked by the revelations of what Stalin had done. Not all of them, I may say, because there were two geneticists called Donald Mickey and Anne McLaren. Anne McLaren became a dame of the British Empire eventually, doing some very important work in embryology. But they were convinced communists, and they actually invited me out to dinner at their home on one evening to try and recruit me into the Communist Party, which they were unsuccessful in. I tried to explain to them that I had very grave doubts about what was happening in the Soviet Union, as, for example, the persecution of the Jews, which they totally denied. This was all Western propaganda. They were both very, very intelligent people. Donald Mickey became professor of robotics, I think, in Edinburgh University eventually. And as I say, Anne became a dame of the British Empire and fellow of the Royal Society. But they were totally in denial about all this at the time. And they both died tragically in a car accident.
Oh, really?
Some years ago. Both dead. I picked up the paper, I read The Guardian one day, and I saw a one-page obituary to Anne McLaren. And I turned the page, and there wasn't a one-page obituary to Donald Mickey. They both died in this car crash.
Oh, that is tragic.
Yeah.
But it's an interesting period of time in the...
It was fascinating, and it was quite difficult. We had, Peter Medawar had a number of American postdoctoral fellows come to work with us, and it was a great culture shock to them. I mean, one of them was Bill Hildeman, who you probably know nothing about. He was interested in the immunology of invertebrates. And he came from a very conventional background, having served in the American Army. He was quite shocked about what was the discussions he used to have over at tea time. But he became very much acclimatized to it all and took it all very much in his stride. Paul Terasaki was another postdoctoral fellow who came in 1957. Paul Russell spent a year or two with us, so it was very interesting.
Major leaders in the field. And so the department then was clearly a very interesting place to work. And what was the science like? What was the hands-on work like? What kinds of tools did you have? What were you able to
Well, when
use?
Peter Medawar was invited to become the professor of zoology at University College, he had some laboratories converted into a more modern, as it was a very antiquated department of zoology. He started in where paleontology and anatomy and invertebrates were studied, but there was no immunological background there at all. So he had a few laboratories modernized and an animal house built on top of it. The building itself was very ancient. It used to be used by I think British Rail for stabling their horses. Actually, there was a sort of ramp going up to the first floor for the horses, so we formed a little immunological unit in that department. Rupert Billingham, one or two postgraduate students, including myself, another one, Elizabeth Sparrow, who was just completing a PhD. Yes, and so we formed a rather separate unit in that department.
So you had an animal facility there.
We had an animal house built, yes, on top of the building.
And you had in vitro.
No, we didn't have culture cabinets. We didn't have sterile culture cabinets. We had virtually nothing. We had bench centrifuges. We had surgical instruments. All the stuff we used was made of glass. We didn't have plastic Petri dishes, plastic syringes, plastic pipettes. We drew our own pipettes out from glass. We washed all our glassware and re-sterilized it.
Many talents.
Including syringes. Yes, that was absolutely, standard practice. We did our own histology in a quite old-fashioned kind of way. So, yes, I think the facilities were quite primitive. By modern standards, extremely primitive.
And yet, perhaps the observations, the skill of observing, was of primary importance, I think.
Yes, I think we went sidetracked by. I have the impression that with modern DNA analyzers and peptide-producing machines and so on, people tend to be a little bit carried away by the technology of it all. It's so easy to produce data, whereas we had to think of what we wanted to do and how to do it and go for it.
So in a field that was just evolving,
yes.
The ideas that one could come up with to explain or potentially explain
yes.
certain observations remains one of the most fundamental concepts in science, I think. And yet, I think you're right. The field has evolved tremendously. We have many, many more tools, but perhaps sometimes to the distraction of our powers of observation. I think
that's probably true. But we are also lucky in a way because so little was known about immunology that virtually every experiment we did turned up something of interest.
Something of interest.
And I mean, Rupert Billingham and Peter Meadow and I became known in America as the Holy Trinity. We published a great many papers on all kinds of topics, and on the adoptive transfer of immunity, for example, and on tolerance, of course, and graft-versus-host disease and so on delayed hypersensitivity, in which we related the allograft reaction, which was then called the homograft reaction, to a form of delayed type hypersensitivity, by showing that in guinea pigs you can actually convert the allograft reaction into a delayed type hypersensitivity reaction in the skin of the guinea pig by injecting antigenic extracts into the skin of pre-sensitized animals. So yes, a great stream of papers was published, and we were known as the Holy Trinity by Americans. I don't know whether it was in a humorous or slightly derogatory.
Oh, I'm sure not.
I leave it to your imagination who the three of us were in that Holy Trinity.
So as the work progressed towards, as you were gathering data, and you had formed a hypothesis about tolerance, and you were readying your findings for publication in Nature, you were asked to do the presentation of this interesting series of findings for the British Society of Experimental Biology.
Yes, that's correct.
What was that like? That must have been very exciting.
Well, it was very extraordinary for me. This was in 1951, shortly before the Nature paper was published. So I was in my second year of my PhD studies, and it shows how generous Peter Weber and Billingham were in asking me, the youngest member of the team, to give their paper. And it had produced a great excitement because it had been advertised, and people realized something important, something very new was going to be presented.
They did.
And the room was absolutely packed with people.
Where was it?
It was in the Royal Society of Medicine.
In London?
In London, yes.
And so this would have been a relatively general scientific audience then?
It was mainly of biologists, zoologists, some immunologists, of course. Yes, it was a very, very mixed audience.
And there was some prediction that something special was going, or
I think people realized that something rather extraordinary was going to be presented. And 50 years later, the British Transplantation Society asked me to present the same paper again, as if I was presenting it for the first time.
Is that right? Was that recorded
Unfortunately,
somewhere?
I still had many of the slides, and so it was very difficult. But the chairman, who was Sir Roy Khan by then, asked me a question. He said, well, Mr. Brent, what do you think is the clinical significance of your experiments? And I said, oh, none whatsoever.
And had that question been asked originally?
That question was put to Peter Medawar by a Cambridge undergraduate student following a lecture which he gave on immunological tolerance in 1960. And he was asked, Professor Medawar, what do you think is this clinical significance of your data? And Peter Medawar said, none whatsoever. And at that time, that was not an unreasonable answer, because at that time we were thinking of it as an interesting intellectual exercise, a very interesting biological phenomenon. But organ transplantation wasn't thought about at that time. And it was because we had to use fetal or neonatal mice, we couldn't see how this could ever be really applied clinically. And of course, it hasn't in the same sense. It has been applied in a different form in reducing the human patient, the immune system of the patient to a kind of primitive level by immunosuppressive drugs or monoclonal antibodies and so on, and inducing tolerance in that way. And at that time, we had no inkling this might be possible.
I know those experiments quite well, having read them in detail. So you'd start with sort of a cocktail of cells, I think, from many different sources of the donor strain.
We tended to use spleen cells, which of course led us into the territory of graft-versus-host disease, because they created tolerance, but reacted against the antigens of the recipient, the histocompatibility antigens of the recipient, causing graft-versus-host disease, which Rupert Billingham and I analyzed in great detail, and we published our major paper in 1959 on that. The initial paper was published in 1957 in Transplantation Bulletin. Yes, we used, but once we realized that we were up against graft-versus-host disease, we used F1 hybrid cells between the donor and the recipient, which had all the antigens required to induce tolerance, but couldn't react against the recipient's own antigens. Or we used bone marrow cells, which were also less potent in causing graft-versus-host disease.
With effector cells, yes, I guess that would be true. And you also changed with time the recipients, so that originally what were fetal inoculations could be done as neonates.
Yes, Rupert Billingham and I decided that we must investigate whether the neonate was still susceptible to tolerance induction. And we spent a lot of time devising an intravenous route for the inoculation of cells directly into the bloodstream of the neonate. And we just found that we could do this by using an intrafacial vein, or we could use the veins on top of the head, where there's less bleeding on the whole, probably easier to do. And we were very gratified to find that in some strain combinations, like the one we used to a large extent, which was A to CBA or CBA to A, which was whether there were H2 differences, but only of class 1 differences, not class 2 differences. There it was still very easy to induce tolerance in the neonate. And that facilitated our analysis of the problem enormously, because we were able to do many more experiments. We didn't lose mice in the way we did when we injected the cells directly into the fetus, which was very hit and miss. I mean, the mortality we experienced there was, of course, turned out eventually to be largely due to graft-versus-host disease, but was also partly technical.
Even with a good idea, an interesting hypothesis, acute observational skills, scientific research can have setbacks and false starts and a wayward path sometimes. What was it like when you had formulated this series of experiments, and then finally there was a set of mice that accepted their skin grafts? Well,
we worked for about 3 or 4 months very unrelentingly before we had our first positive result. And that wasn't, that was a mouse which was partially tolerant. The graft survived for quite a few weeks, but not indefinitely. That was our first glimmer that we were actually achieving something, and which helped us to continue with enthusiasm, renewed enthusiasm. And then eventually we especially, of course, but both our neonatal injections and also with intrafetal injections, we did have very great successes. There was one particular litter which was of 8 mice, where every mouse was totally tolerant. I mean, perfectly tolerant. This was a litter which had been injected on the 18th day of gestation, so in utero. And we couldn't believe that this could possibly be true. There must have been a mistake somewhere. So we inquired with the animal house, and the animal technician had actually made a mistake and had given us an F1 hybrid litter, which accepted the skin grafts automatically and perfectly. So that was a very great disappointment.
That's a big disappointment.
But we did get some very good results, and on one occasion, Jean Medwar, Peter Medwar's wife, they called them the super mice, and so they came known as the super mice. And one of our super mice leapt off the table and onto the floor of this old laboratory and was in danger of disappearing down some mouse hole or some crack in the floor. We were actually terrified. So we tried to plug up every hole in the floor, and our way of collecting this mouse again was to take a small cage. It was a female mouse. We collected a cage, put a male mouse into it of the same strain, and then waited to see what was going to happen. And lo and behold, there was sexual attraction, and we managed to catch the mouse.
And so the data was preserved.
Right.
The work that emerged in the early 50s was enormously exciting and ultimately very inspirational, and obviously included in your doctoral thesis. When Peter Medawar received the Nobel Prize in 1960, he wrote a lovely letter to you saying that it was your PhD thesis really that won the prize and not his. He seems to have been a most generous man and an inspired leader.
He was very generous indeed. I mean, he was also very sad that Ray Owen hadn't been included, and there was some exchange of letters between Ray Owen and Peter Medawar. Ray wrote to Peter congratulating him, and Peter wrote back, and I have copies of these letters. Peter wrote back and said how very sad he was that Ray hadn't been included in the Nobel Prize. Yes, I think there was a great generosity there, and which I appreciate enormously. Yeah.
And so, what were they like personality? The two Rupert Billingham and Peter Medawar.
Well, Rupert and Peter were totally different personalities. Peter was an intellectual, very cultured, very interested in the arts and music, and passionate about Wagner, Richard Wagner, to my great sorrow. He actually encouraged me to see the whole Ring cycle at Covent Garden in the 1950s, which I did, and it was an interesting experience. But I never became a fan of Richard Wagner. I won't tell you why, but I could tell you why, but I won't now.
I'll ask you later.
I read Richard Wagner's 1856 paper, published, of course, in a German philosophical journal, in which on Jewishness in music, and it was a vicious diatribe, anti-Semitic diatribe, of the worst possible kind. You can see why Hitler adopted Wagner as a great hero.
Amazing.
And that rather put me off Wagner. I know it shouldn't do, theoretically it shouldn't do, and someone like Barenboim, the Israeli conductor and pianist, has managed to rise above this by introducing Wagner to an Israeli audience for the first time. And there was quite a hiatus there, because many of the audience objected to it. And so there was a discussion about it all, and at the end of the discussion, Barenbaum said, well, those who want to leave, please do leave, and some did, and the rest gave them a standing ovation at the end. So, yes, but...
And Billingham.
Peter Medwell was also a great sportsman. Mm-hmm. He played cricket and squash, and he and I played squash a great deal together. We were roughly of the same standard. We played chess together quite a lot, also again roughly of the same standard. Whereas Rupert was much more restricted in his cultural interests. He read a lot of novels connected with the sea and with the Navy. He was an ex-naval man who had survived life in destroyers escorting ships in the Antarctic, going to Russia to deliver supplies. So there was a great temperamental difference between them, but they were very complementary in a way. Rupert was very innovative experimentally, and so it was, they complement each other very well. And I sort of was betwixt and between the two in a way, both.
So quite a team, a complementary team.
Both in terms of initials, because Peter Medwell always published papers in alphabetical order. So it was always Billingham, Brent, and Medwell. And later when Peter and I published together, it was Brent and Medwell. But yes, he was very generous, and he was an amazing man. He was multi-talented. He wrote a large number of books which became very popular in Britain and America as well, I think. And many of those books were written after his calamitous stroke in 1969, from which he recovered physically not very well. He was partly paralyzed for the rest of his life. But intellectually, he made not a full recovery, but a sufficient recovery to be able to write all these books and still to help supervise some research in his laboratory, in which Liz Simpson, for example, worked very actively.
Extraordinary career. You were also good friends, I believe, with Norman Shumway, who did the work, much of the work leading up to the first human heart transplant. Where did you come to know him?
Well, we weren't close friends, but we knew each other. We met each other at congresses, and Shumway invited me to give a talk in his department in San Francisco. And I admired him enormously. He was a very modest man, really, genuinely modest, and almost self-effacing in a way, so that I can understand that he was rather upset by being overtaken by Chris Barnard, who used his technology, but published very quickly this first heart transplant in 1969, I think it was.
67.
67, yes. So, yes, and I was very pleased that Shumway received the Nobel Prize eventually.
It was a very exciting time, I think.
Yeah, it was, yes.
So you've had a wonderfully stimulating career, it seems to me, and you've had an impact way beyond what might have been originally expected from just injecting fetal mice that might not have any clinical impact to be seen at the time, but clearly has had an enormous impact in many parts of immunology. What words might you have for a young scientist starting out today?
I think I would say to young scientists, go for investigations which really matter, not necessarily investigations which will be popular with the press or with the establishment, and follow your own instincts and press on regardless of the results and how the results are received by the scientific community at large. I feel that that is probably an old fogey's idea. I find that medical researchers make claims these days which go well beyond what they should claim, because it's one way of getting research grants. And very often big claims are made, and then you hear nothing more about these these claims, they just sort of disappear in the sands of time. And I think one has to be a bit more realistic about that and be more careful not to raise expectations in the public for magic cures or magic innovative procedures which may eventually disappoint. I know that immunology has been described as having come to the end of its life by Macfarlane Burnet, for example, in his dotage, said, well, there's nothing more to be invented and discovered in immunology. It's just a matter of dotting the I's and crossing the T's. That's what Burnet said and wrote in one of his latter-day publications. But there is still a lot to be discovered in immunology, as I discovered myself here at this conference. I mean, some of the papers are absolutely fascinating and complicated. I mean, the trouble with immunology is it's so complex that people, medical students, tend not to understand it very well. I know when I arrived at St. Mary's Hospital Medical School teaching immunology to medical students, it was hard work compared with zoology students at Southampton University, who are very receptive to new ideas and who didn't mind if you told them, well, we aren't quite sure whether it's this way or that way, it could be either way, and so on. Medical students like to be spoon-fed and be told things are like this or like that, and that's it. So immunology is still incredibly complex, becoming more complex. One hopes that one of these days there will be kind of catharsis and everything will fit together and become simpler again, but I don't think it will happen that way.
Somehow I think not, but at least it becomes an endlessly creative pursuit to try and understand the complexities of immunology. I thank you very much for contributing these thoughts to our history project.
Well, Dr. Hall, thank you very much for inviting me. I feel very honored.
We're very honored.